What is up, YouTube? Today I'll be showing you 3 simple tips to help you improve your Python skills. Now, as a Python beginner, if you're watching this video, you're bound to learn something that can help you think tactically or practically, whether it's in a project or in a future interview. So it's definitely good for you if you are a Python beginner or even if you're intermediate. So if you enjoy these types of videos, please remember to subscribe to the channel before we get into it. And enough being said, let's get started. Okay, so the first example I have in this video is you want to avoid returning none as much as possible in functions because that can prove problematic down the line when you're working with big programs where you're using that none result in some if statements here. So that'll make a lot more sense once I go through this example. So imagine me as a beginning Python programmer where I wrote this simple function here called careful divide, where I try to divide 2 numbers, a and b, and if b is 0 in algebra, you're not allowed to divide by 0. I'm going to accept 0 division error and return none. And later on in the program, I'm saying if I do get none, I'm going to say if not result. So none is false equivalent. I'm going to print your inputs are not valid. So in this example here where I have 1 and 0, we have 1 divided by 0 once I pass to the function, and it's going to go into the accept statement, return none. The result's going to be none, and it's going to print this result. So that makes sense, and as a beginner Python programmer, I'm oftentimes drawn to none. So I'll show you why that could be an issue here in a second. So we did get what we expected, your inputs are not valid, and they're not. But what if we do 0 and 5? Let's say just 0 divided by 5. Once again, 0 divided by 5, if you know some algebra, is just 0. So this is actually a proper mathematical expression. You can do this. And if I go ahead and run this program, what I get is your inputs are not valid. So that doesn't make sense because 0 divided by 5 is actually 0, which makes sense, and your inputs are actually valid. And the reason that's an error is because when we did 0 divided by 5, result equals 0, and 0 is actually false equivalent as well. So based on the way I wrote this program, I actually induced a bug by using none in that scenario, which can be really tricky for me to find, especially in a big program. So we really want to avoid doing this. And a common way to combat this, as I mentioned at the beginning of this tip, is to use exception as opposed to returning none. So let's say accept 0 division as e. So that's exception. I want to return or raise value error. Raise value error. I'm going to say inputs are not valid. Okay. Now, as opposed to giving the user flexibility in terms of using that none and doing some logic after that, what I'm going to do is I'm going to force the user to change how they're operating based on this exception. So we'll no longer run into that area. So now we have x and y, x equals 0, y equals 5. I'm going to say try result equals careful divide, and I'm just going to pass in x and y. So x, y, and accept value error. I'm just going to print invalid. And the next thing I'm just going to do is say else. We just print result. So this is a much better, more robust way to deal with the situation because we put it on the user now to do some action as opposed to passing that silent bug that we did before. So if I run this, it should be fine. As we saw, we printed the result. And once again, if we do 5 divided by 0, which is invalid, we should get what we expected originally. So invalid. Perfect. So I hope that example makes sense. If it doesn't, please let me know in the comment section below. And let's jump to example 2. Okay, so the second example I have for this video is I want beginners to be familiar with something called catch-all unpacking. So this is a term many beginners might not have heard, and you're going to see this more in more advanced or intermediate programs, maybe in practice as well. So it's something you should be familiar with and know why it could potentially be more powerful than simple list indexing as you see in this example. So what I have in this example is that I have these house ages in terms of a list that's currently unsorted. And what I do in the next line of code is I just sort them in descending order. So the first element in that list would be 20. So I'm trying to show the user in this program the oldest house, the second oldest house, and the other houses just by doing some hard coding indexing here. So this is a really common method that beginners use to just simply hard code the indexes here and do something with them. We'll just know that a lot of the times that can prove error prone because you could be susceptible to one-off errors. Let's say you have a big program and you manage to change one boundary, but you forget to change another boundary, and that can cause some error that could be difficult to track down. And also this can be problematic in terms of readability and noise. So you can actually improve what you're doing here by using the catch-all unpacking operator in Python. So we could do the exact same thing here. So I'm just going to uncomment this and show you that we can do exactly the same thing by unpacking as opposed to using indexing and using the star character to get the remainder. So the star character is just telling me, or just telling the program that I want everything else in a list other than the specific unpacking that I'm calling for here. Okay, so I called oldest, which is getting the first element in the list. Then I called second oldest, which is getting the second element in the list. And if I use the star operator here, it's just telling Python that I want the remainder of the unpacking in a list. So if I go ahead and run that, we'll get the exact same thing. So that's nice because if we do manage to change the boundaries in a program, that can help us later on to avoid errors. And you can see it's much cleaner. Just we did that in one line of code as opposed to 3 lines of code here. And we don't have to hard code any indices, which can, as I said, prove problematic. And what's cool about this star operator as well is that you can have it anywhere in the unpacking. So it doesn't have to be at the end to get the remainder on the right. You can actually get the remainder on the left as well. So you can tell Python here, we know the last 2 elements in descending order are the youngest. So if we go ahead and print this, we'll actually get the youngest and the second youngest and the others as well. So you can use this anywhere to index how you want. So let me just uncomment this to remove noise and uncomment this as well, or comment this. So if I go ahead and save that, we can see that we got the second youngest is 1, the youngest is 0, which makes sense, and then we just get the remainder. So it's pretty cool how we can have this star operator to unpack everything else in any scenario of unpacking, right? But another thing you have to note about the unpacking operator is that you can't have 2 unpacking operators. Python will throw an error. So if I go ahead and save that, the linting itself is already throwing an error, so we can't actually use this. So multiple starred expressions in assignment, you can't do that, so just be wary of that. And finally, what I want to show you here is that the star operator always returns a list, even if it's an empty list. So in this example here on the bottom, what I have is I have some random list 1 and 2, first item, second item, and I have the starred expression as I mentioned earlier. And let me just comment all this because we don't need that anymore. So what's going to happen here is I'm going to get the first item, I'm going to get the second item, and there's going to be nothing left to unpack in this scenario. So what's going to happen here is I'm just going to get an empty list. Okay. So that's just to be expected, and just know when working with the unpacking operator, if there is nothing left to unpack, you will get an empty list. And yeah, that's being said in terms of that example, that can help you in terms of the readability of your code in certain scenarios, as I showed above, and it can make your code less error prone in the future. So try using that and just be aware that that exists, and hopefully in future programs you recognize that and you're able to use that in one of your future projects. That would be great. So let's jump into the third example. Okay, so the last example I have here in this video before I let you guys go is that I want to introduce the concept of variable positional arguments in Python, or also called Star-args. So this is actually kind of similar to the example we just went through, but it's the same thing, but in terms of the positional arguments in a function. So you may have seen this operator in a function and you may have been confused, or you've maybe never seen it at all. So we're just going to go over that in example and why it could be useful in certain scenarios. So we have this function called define log, where we just pass a log message and values, and we do some logic with it. So if not values, we just print the message. Else, we're going to loop through all the strings in the values, and we're going to join them with a comma, and then we're just going to print them in this f string here. Okay. So let me actually comment this out because that doesn't matter for right now. So this is just our first example. So we have the first function call where we say my numbers are 1 and 2. In the second function call, what we have is hello, my numbers are empty list, because this user doesn't have any numbers to pass, let's say. But they still have to pass a list because the logging function itself will throw an error if you don't have a list. Let's go ahead and run that and show you what it gets. So we just get my numbers are 1 and 2, and hello, my numbers are empty, because it was an empty list. So that makes sense. But a lot of times in programs like this, you don't want to force the user to have to pass in an empty list, because it can be cumbersome and it could just be redundant. Like the user shouldn't have to do something like that in this scenario. So what you can do instead is pass something called the Star-args, where we have a variable amount of positional arguments, and avoid this scenario where we can slightly improve the readability. And a lot of the times using this coding technique is preference to the programmer, but you will see this in some intermediate or advanced projects. And in fact, I have seen this in practice at my job as well. So it's something to be familiar with and realize that it exists. So as opposed to passing in actual values, which you have to pass into the function for it to work, what you can pass instead is the star values. So what the star values will do is you have the choice to pass in values. So in this scenario, I can pass in 1 and 2 as optional remaining values. Otherwise, if I don't pass in any values, it's just going to evaluate to an empty list, as you saw in the second example of this video. So if I go ahead and run this code, we're going to get the same results in both functions with slightly improved readability, which is cool. Okay, so we got my numbers 1 and 2. We got the same exact thing, and we're able to use the Star-args as opposed to forcing the user to pass in an empty list, which can be annoying for the user. So that's just another cool technique in Python you could use to slightly improve the readability. And I hope you guys learned absolutely anything in this video. If you did, please like, comment, subscribe. If you enjoy content like this and you are a beginner Python programmer, I really recommend you watching this channel, because I do go through some concepts that you don't find in regular tutorials on YouTube. So if that's the case, like I said, subscribe and let me know what you want to see in the comment section below. If you have any questions, let me know as well. As always, guys, stay tuned. Thanks for watching.